Hello, welcome to another module in this massive open online course on the principles of CDMA, MIMO, OFDM wireless communication systems. So, we are looking at a characterization of the wireless channel, and today we are going to start talking about a new aspect, that is the Doppler effect. So, the Doppler, so we are going to start focusing on the Doppler effect in a wireless channel. And now for the Doppler effect, basically we have to consider a scenario in which, or consider a scenario in which the mobile is moving or the user is in motion. That is basically to say the wireless user is in motion, there is relative velocity, there is relative motion between the transmitter and the receiver, or there is a relative motion between the base station and the mobile, because the user is moving, correct. And let me just schematically depict the scenario here. Let us say I have a base station which is transmitting its signal, and I have my mobile, this is the mobile. So, the base station is transmitting the signal and the mobile is moving, it is moving either towards the base station or it can move away from the base station. So, mobile is in motion. So, the mobile is moving, and this motion leads to a change in the frequency of the signal received at the mobile. This relative motion between the base station and mobile leads to a change in the frequency of the signal received at the mobile. So, this leads to this motion change in the frequency of the wireless signal received at mobile. So, this leads to a change in the frequency of the signal received at the mobile, and this change in the frequency, and this basically this phenomenon, this is termed as Doppler effect. That is this change in the frequency of the signal received because of the motion of the mobile, because of the relative motion between the base station and the mobile. This is termed as the Doppler effect. So, what is the Doppler effect? Doppler effect, which is also sometimes simply termed as Doppler in the wireless channel. What is this? This is the change in frequency of received signal due to motion between transmitter due to motion between the transmitter and the, so it's a change in the frequency of the wireless signal due to motion or relative motion between the transmitter and the receiver. Now, how to calculate this Doppler, this Doppler effect, or the shift in the frequency or the change in the frequency that is arising because of this Doppler effect. For that we have the following relation or the following principle. Let us consider, so we would like to calculate the calculation of Doppler. We would like to calculate the Doppler shift, and for that consider a scenario in which I have a base station. This is, let us say, my base station, and let us say I have a mobile which is moving at an angle of theta. So, this is my mobile which is moving at an angle of theta. So, I have the mobile moving at an angle of theta with respect to So, I have a mobile which is moving, and this is moving at an angle of theta with respect to the base station. Let us further say that this mobile, the velocity of this mobile, velocity equals v, and then in this scenario the Doppler shift Fd is equal to v cosine theta divided by c times Fc, where Fc, where c we have seen previously. So, let me write this clearly over here. The Doppler shift Fd equals to v cosine theta divided by c times Fc. V is the velocity, theta is the angle, c is the speed of light, or basically the speed of an electromagnetic wave, and Fc, our Fc is the carrier frequency. Fc is the carrier frequency of the signal. Alright, so the Doppler shift Fd equals v cosine theta by c times Fc, where v is the velocity of the the mobile, theta is the angle of the mobile with respect to the base station, c is the velocity of the light or the velocity of the electromagnetic wave, and Fc is the carrier frequency. And now you can also observe from this expression that if 0, right, and therefore the received frequency Fr of the received signal this is given as Fr equals Fc plus Fd, where Fd is the Doppler shift, which is equal to Fc plus v cosine theta by c times Fc. So, the received frequency Fr, this is the received frequency of the received signal, is equal to Fc, this is the carrier frequency, plus v cosine theta by c times Fc, this is your Doppler shift. So, the received frequency is the original carrier frequency Fc plus the Doppler shift. correct. And now you can see from this expression that if 0 less than equal to theta less than equal to pi by 2, then cosine theta is positive or cosine theta is greater than or equal to 0. Therefore, Fr which is equal to Fc plus V cosine theta by C times Fc, since cosine theta is positive, this is greater than or equal to Fc. Therefore, received frequency is, what does this mean? This means that received frequency is greater than or equal to the carrier frequency. And when does this occur? This occurs when theta is between 0 and pi by 2, that means the mobile is moving towards the base station, and this implies occurs when 0 less than equal to theta less than equal to pi by 2. This implies the mobile is moving towards So, if the mobile is moving towards the base station, then 0 is theta lies between 0 and pi by 2, cosine theta is positive, therefore, the received frequency Fr is greater than the carrier frequency Fc. On the other hand, if theta is greater than pi by 2 and lies between pi by 2 and pi, if that is if theta is an obtuse angle, if pi by 2 less than theta less than or equal to pi, then we have cosine theta is less than 0, and therefore, Fr equals Fc plus V cosine theta by C times Fc. This quantity is less than Fc, since cosine theta is negative, which implies that basically my received C frequency is less than the carrier received frequency is less than the carrier frequency, and this occurs when pi by 2 is less than theta less than or equal to pi, which implies basically mobile is moving away which occurs when the mobile is moving away from the base station. Therefore, we have seen two cases. One is when theta is between 0 and pi by 2, that is when mobile is moving towards the base station, and then we have the received frequency, the Doppler shift is positive, therefore, the received frequency is greater than the carrier frequency. On the other hand, when theta lies between pi by 2 and pi, cosine theta is negative, therefore, Fr is less, that is the received frequency is less than Fc, the carrier frequency, and this occurs when the mobile is moving away from the base station, alright. Okay. And now, let us look at a simple example to understand the Doppler effect better. Let us consider a simple example. So, let us consider Fc equals 1.85 gigahertz, and we have vehicle moving at 60 miles per hour, at theta equals 30 degrees, that is the angle of the mobile with respect to the base station. We would like to ask what is the questions we would like to ask are what is the Doppler shift and what is the received frequency. What is the Doppler shift and what is the received frequency. For this purpose, now look at the following. I have the velocity equals 60 miles per hour, which is equal to 60, because 1 mile is 1.6 kilometers roughly. This is 60 into 1.6 kilometers per hour, which is equal to 60 into 1.6 into 1000 meters divided by 3600 seconds, which is basically equal to 26.8 meters per second. So, 60 miles per hour, we have calculated the equivalent velocity in meters per second as 26.8 meters per second. Now, let us look at the Doppler shift if d equals v cosine theta divided by c into fc, if d is the Doppler shift. This is equal to, well, 26 v is 26.8 meters per second times cosine of 30 degrees, theta is given as 30, divided by c, which is 3 into 10 to the power of 8 meters per second, that is the velocity of light, times fc, which is 1.85 gigahertz, that is 1.85 into 10 to the power of 9. And now I can substitute cosine 30 degrees equal to square root of 3 by 2. So, this is 26.8 square root of 3 over 2 divided by 3 into 10 to the power of 8 times 1.85 into 10 to the power of 9, and this is equal to basically this is 143, approximately equal to 143 hertz. So, the Doppler shift for this scenario, the Doppler shift is given as 143 hertz, that is for a vehicle moving at 60 miles per hour at an angle theta equal to 30 degrees and carrier frequency 1.85 gigahertz. We have calculated the Doppler shift as 143 hertz, and the received frequency, that is Fr equals Fc plus Fd, which is equal to 1.85 gigahertz plus 143 hertz. This is the received frequency, where Fr is the received frequency. Okay. So, this what we have seen is basically in this module we have defined the Doppler shift, we have illustrated how to compute the Doppler shift for a given velocity and angle theta at a given carrier frequency, and also we have seen a simple example of the Doppler shift. Alright, so we will end this module here and look at other aspects in the subsequent modules. Thank you.